Hi everyone, welcome to another series on our topic called data analytics techniques. So this is the part three of the series. If you have not watched the first two parts, I kindly recommend you pause this video right now to go check the first two parts because the knowledge they are building on one another. So today we'll be talking about basic and advanced statistics data analyst or a data scientist should learn. So we'll talk about basic and advanced statistics a data analyst or a data scientist should learn. So the question is, why is statistics important for a data expert? So I would say that statistics is the discipline that concern itself with the collection, organization, analysis, interpretation, and presentation of data. So that sounds like what a data analyst do. A significant portion of data analysis principle is rooted in statistics and by extension, mathematics. I mean, that's like very profound, like what a data analyst or data expert does. Most of the principles are rooted from mathematics, then up to statistics. So we kind of make inference from all of those principles. One thing you need to be rest assured is that you don't have to be an expert in statistics, or you have to be a sort of a mathematician before you can excel as a data analyst or as a data expert. You just have to understand some basic fundamentals or the principles as how it works, not necessarily how to run the table yourself or get a calculator or stuff like that. So today we'll also be talking about measures of central tendency and variability. So measures of central tendency, these are basically the four measures of central tendency. You might look up online and they might tell you there's more to this. And so they are called mean, median, mode, and range. You might wonder, this is very simple. Why do I need to care about this as a data analyst or as a data expert? Because for the most part, you would do this a lot, and there are instances where you would want to run the median or you want to run the mean just to get an accurate analysis. So basically, central tendency means you just want to see how is data or how an information is distributed. Is it like is it like evenly distributed? Is it unevenly distributed? I'm going to talk about what evenly distributed means or unevenly distributed. But first of all, just in case you hear people talk about measures of central tendency, you know they're talking about mean, median, mode, and range. But as you work as a data expert, probably people would not ask you to run what you call measure of central tendency. They might tell you find the mean, find the average. So another word for mean is also called average. So if somebody tells you find the average salary of these two groups, then you know what they ask you to do is just to find the mean value. So the average of a set of two or more numbers. So mean is the average of a set of two or more numbers. So this is just to jog your memory on if you've forgotten about some of these concepts. Median is the middle number in a sorted list. So if you have a number, for you to get the median, you have to sort the number either ascending or descending order. Y mode is the number most frequently occurring in a population. So sometimes you say, what's the most populous country in the world? Or what's like this? So we are looking at mode, or you are trying to look at, that might not be a good example, but just know you want to know how often something occurs, or you want to check a product that people buy more often. So that's also like you're trying to see, that's like the mode sort of. Range is the difference between the highest and the lowest value. So either the highest income minus the lowest income. So you just want to get the range. So some of these measure of central tendency, you use them more often than one another. So let's find an example of how you can identify like a mean, median, mode, and range. Given that you have the set of numbers 2, 3, 7, 3, 2, 1, and 2, so find the mean, median, mode, and range. Mind you, as a data analyst, you would not have this kind of question or just this very simple question. It's going to be more complex than this. But for the purpose of showing us practicality, that's why we are using just this very few number. So what you have to do is just to sum the numbers that you are given for you to get the mean and divide them by the count of the number. So if we are given 7 numbers here, you add the numbers together, divide them by the count, which is 20 divided by 7. If you use your calculator, you would get approximately 2.86. If you're asked to get the median, you just have to sort of order the number in ascending or descending number order. So for in ascending order, so this is 1, 222, 337, or you're going to have 7, um, 3, 3, 3, 222, 1. So if you count this number from, you take out the first one, you take out the second one, take out the first one, take out the second one, take out the first one, take out the second one, you'll be left with the middle number. An easy formula for this would be n plus 1 divided by 2. N means the counts that you are given. So we know we are given 7 numbers, right? So you just have to do 7 plus 1 divided by 2. So 7 plus 1 is 8. 8 divided by 2 is 4. So if we count 1, 2, 3, 4, it's going to give us the median. If we count 1, 2, 3, 4, it's going to give us the median. So just in case you have a larger number, you don't have to start counting one after the other. But when you run a program as a data expert, the software you're most likely going to be using would have a formula or would have like a code for you to be able to run the median and the mean easily without having to run the formula behind it. Y mode is the number that appears more often. So this is 2, 2, 2, and range is 7 to 1. Remember earlier I spoke about if a data is evenly distributed. So a data is evenly distributed when the mean, the median, and the mode, the figure or the result is the same or is similar. So technically, we can almost say this number is evenly distributed. So when you find the mean, the median, the mode, and the numbers are similar or they are the same, it means the data is evenly distributed. As a data expert, if your data is not evenly distributed, that's the data that you're giving for analysis is not evenly distributed, they might actually lead to bias in the results that you get. And there are ways to work around it to deal with issues like that. When we talk about potential issues with the data set, we'll be talking more about that. Um, so let's look for a case study, like how do you apply this in your everyday life? So imagine you track your weekly actual cost of living. So most week you incur a consistent expense around $100. However, in one exceptional week, an unexpected emergency arises and you end up spending $700. So let's say we have data for just 4 weeks. And so the prior 3 weeks, you were spending $100 a week. You spent 100, 100, 100, $700. So if you add this up together, it's going to be $1,000 divided by the mean. So that's 1,000 divided by 4 is going to be $250. So if somebody asks you, what is your average spending per week? And you tell them my average spending per week is $250 because you found the mean, this is actually inaccurate. I mean, in a practical sense, right? Because what you are trying to find is, um, this is actually inaccurate in a practical sense because what you are trying to look for is probably you're trying to budget for the week and the person just want to give you $100, right? So and the person eventually gives you $250. But if we look for the median and we try to look for, oh, what is going to be the middle number? So it's going to be, what do we have here? We have 1, 2, 3, 4. That's 4 plus 1, that's 5. So 5 divided by 2, that's n. So the formula for median is always n plus 1 divided by 2. So we have how many here? 1, 2, 3, 4. So that is 5 plus 5 divided by 2, that's 2.5. We have 1, 2. So 2.5 is around the middle. So you just have to add this together and divide it by 2. Like I said, you don't have to know all the statistics going behind this. You don't even have to understand this fully well. Just know that median is the middle number when the um list is arranged. So the median here is 100. In this scenario, $100 looks more accurate compared to um the median. So we can say that this data is sort of not evenly distributed. In actual statistics term or a data analyst term, we will call this number, this $100, an outlier. So we will call it an outlier. Also, if we have something like $2 in a week, let's say somebody did a giveaway for you, they bought grocery for you, you didn't spend anything, you only spent $2. That $2 would also be an outlier because that $2 or this $700 is way like outside of what you would spend normally. So that's one of the things you look out for when you look at your data, not just running a table and getting a graph and you're like, oh, I'm done. This is the result. Your results might actually not be accurate or might not be a true representation of what things are. So there are ways to also deal with this. So we'll talk about that later. So it says when applying the average to analyze the data, it might mislead you. The mean could give you a figure that doesn't accurately represent your regular spending pattern because it's heavily influenced by one week outlier with the 1,000 with the 7. This is supposed to be 700. 700 expenses at the median might be more accurate. So let's go to other statistical measures. So we have something called standard deviation. So the standard deviation is how far the distribution of your data is from the mean. The lower the standard deviation, the better it is. So what we want or what we'd expect is we want a lower standard deviation. So if you're trying to compare two data together and one has a lower standard deviation, then the one with lower standard deviation is okay. So let's look at something like this. So look at example 1 data and example 2 data. So if you had up all this first data together, it's going to give you 150. If you divide them by 5, that's the count, it's going to give you 30. So the mean is 30. Also, if you do this, add them together, it's going to give you 150. If you divide them by 5, it's going to give you 30. But there's something different about these two data. Even though the mean is the same, you're like, oh, if you take this back to income or take this back to weekly expenses, so imagine this person over the week spends $10, $20, $30, $40, $50. So if you can have like a sense almost what the difference between these two data is, like I think they're increasing by 10. Why this person here this week spends $40, spends $10, spends $5, spends $5, spends $90. This is a little bit inconsistent. So how do we know that, like, what would be the standard deviation? How do we know how far this data is like distributed from the mean? So what you do is sort of you would subtract each of your data points from your mean. So what we do is you subtract 10 minus 30, your number you get, 20 minus 30, 30 minus 30, 40 minus 30, 50 minus 30. You sort of square them so as to take away the negative. You divide them, you do some more math behind that. When you do that, if you do this also 40 minus 30, 10 minus 30, 5 minus 30, you will notice that this data we have a bigger standard deviation compared to this data. So that's something you also want to look out for. So also there are other factors where you might want to use a standard deviation in your analysis. So, but mind you, you would not be computing standard deviation yourself. You just have to understand, oh, this is what goes on behind the scene. And when you want to sort of communicate your analysis, you know, oh, this is how this came up and this is how it is useful. So we have something called degrees of freedom. So degrees of freedom is the number of values in the final calculation on the statistics that are free to vary. So usually it's basically n minus 1. So where n is the sample size, we usually prefer a larger sample size or we prefer a larger degree of freedom. So when somebody is trying to say, oh, this sample size is small, or they say, oh, this degree of freedom is small, what they are trying to tell you is the same thing. So don't allow somebody try to, but most likely people will use the sample size, or if they say the sample is small. So if a sample is 1,000 or 100,000, the degree of freedom is basically 99999. So it's just trying to minus one. So degree of freedom is like how free are we to vary on your result? Because if you are trying to I one time I was looking at a survey and they used about, let's say, 20,000 the person, or I think it was about 3,000 to represent the whole country results. And I was like, this would not be very reliable. So imagine somebody uses, like, let's say 3 million to 3 million sample size to represent the whole population. Doesn't mean the person that used 3 million would be more accurate, but like they have a higher probability of being accurate. So they have a higher degree of freedom compared to somebody who has, let's say, 3,000 sample size to represent the whole population of a country, where the population is like about maybe a lot of persons, right? So that's when you talk about degrees of freedom. So normally distributed is when the mean, median, mode are equal or similar. So like I said, if you look at this, the median, the mode, and the mean for this value or this distribution is 3. So what other statistical measures do we need to know? So we have standard error. Standard error, so this kind of indicates how different the population mean is likely to be from a sample mean. It tells you how much the sample mean would vary if you were to repeat a study using new sample from within a single population. Usually we want a lower standard error. So this is a practical example. If population mean is 25 and the sample mean is 23, then the standard error is 2. So what does this mean? It means that um, let's say you have a population of 100,000 person, right? And you sample just 10,000. But let's say before you sample the 10,000, you could actually you could sample everybody because you have the capacity, or they give you an accurate data. And those 100,000 person, their average income is actually 20,000, like $20,000 or 20,000 pounds or whatever per month. For some reason, when you selected 10 people to be representative of the 100,000, when you asked those 10 people what their average salary was, they told you that their average salary was 15,000, but the whole population told you that their average salary, when you looked at it, was 20,000. So the standard error there is the 5,000. So standard error is basically the difference that would happen if you sample like the whole population instead of doing a study on the mean. So, and you would sort of understand this in different contexts. This is not just a population sample context. So when we mean population in data analysis, we don't necessarily mean population of a country. Population means just everything in a particular geography or a particular context that you're trying to study, while sample means a sub of that thing that we're trying to study. So why confidence interval is the range when you plus and minus the standard error from the sample mean. So in this context, so the lower confidence interval is going to be um 23 minus 2. So that is the sample mean that we got, minus 2, because the standard error is 2. The upper confidence interval is going to be 23 plus 2. So why the confidence interval is 21 to 25. So what this means is that even though, and we do this a lot, so when you do your analysis, you always have to give room for error. Like error are things that we speak about when we talk about like data analysis. That so what this mean, or what this interpretation, or how do you interpret a confidence interval, is that when you do your analysis and you get 23, there are some statistics you can do behind it and see that, look, I'm very confident that even though you sample the whole population, or you take a different sample from the population, or you check the actual population 100 times, I'm sure the figure would be around 21 to 25. That's like one thing I'm very sure about. Zira is going to be I mean, lesser than, it's going to be between 21 to 25. And with this person is actually accurate. So, but there are other things that you would speak when it comes to confidence interval, but this is just what it looks like in a simple term, meaning that we are confident our population results will be within this range. So that's basically what confidence interval is. So you hear something called statistically significant. Oh, this thing is significant, or this thing is, and this is one term you will use a lot, meaning that we are more than 95% confidence that our result is accurate. Meaning the chances of error is less than 5%. So that's 5% means 0.05. In general, less than 0.5%, 0.05 is what we expect. In medicine, you have to have over 99% accuracy. You have to be 99% accuracy. So this is the basics for accepting or rejecting our hypothesis. So one thing we spoke about in the previous series of this video, we spoke about hypothesis. The hypothesis is an educated guess of what you think your result is going to look like. So let's say I have an hypothesis that income matters when it comes to health. So that is my hypothesis. That's my H1. So why my H0? That is the alternative is that income doesn't matter. So, or I have an hypothesis. Let's just keep it simple. I have an hypothesis that income does affect health. So when I sort of run my analysis and my p-value as like that's what a term they call this. That's the percent value. I think that will be what it is. And my p-value is not less than 0.05. Then I don't have the evidence to say that um income affect health. Remember, look at the word I'm using. I'm not saying income does not affect. I'm just saying I do not have the evidence to say that income affects health. So, but if my p-value is less than 0.05, then I can't say that, oh, actually, income actually probably most likely affects health. So the p-value is more like the error, or like the part that is not data when there some things are running behind the scenes, some algorithms or mathematical equation which is making like this less than 5%. We are saying, okay, I want to be more than 95% confidence. That means what happened is, so if you use this in medicine, so if you take 100% and you give them a medication, before you can actually take out that medication to everybody. So if you want to use a 95% like confidence, so that means that 95, that's at least more than 95 people have to respond positively to the drugs. So, and if just 4 persons do not respond positively to the drugs, most times we don't have numbers that are 0.1, you might have 0 point something, you might have just whatever. So if you have, let's say, less than 5% who do not respond to the drug, then we are confident that this drug or this medication is actually great. But in medicine, actually, they don't use 95%, they use 99%. So for there to be a medication out there, if they bring 100% to come use this medication, more than 99 persons or more than 99% something must happen that before they can accept that, okay, this medication is actually a good medication. So it tells you how this sometimes can be difficult to achieve. So so just understand when we say, oh, statistically significant, what they are meaning is there's something called for other fields, what they use most time is 95% and 5%. So it's medicine that probably uses 99%. Some fields use 90%, but most times your default setting for the software you're going to be using is 95%. So just know when you are trying to calculate something and you see that the p-value is less than 0.05, then you know that, oh, this is actually statistically significant. Mind you, you don't still have to understand all of the technical jargon going behind the sign, but this is just so you can have an idea. So maximum is the maximum number, the largest number in a distribution. Minimum is the lowest number in a distribution. Probability, you probably know this, the likelihood of an event occurring. So it ranges from 0 to 1, or you could also speak about this in percentage. Or I have so when there's a rain forecast, it tells you, oh, the probability that it will rain is 20%. So what they are telling you that is the probability that's going to rain is 0.2, or or the probability that somebody's going to make it in life is 9%, or this. So just know that probability ranges from 0 to 1, or they speak in terms of percentage. So that's the likelihood of an event occurring. So also, most of the time when you speak as a data expert, you speak in terms of likelihood, or the likelihood that this is going to happen is this. And most of our stuff ranges from 0 to 1, like most of the things we speak about, but the other things that don't range from 0 to 1. So other statistic measures, so you get something called odd ratios. Some persons in their lifetime might never use something called odd ratios as a data expert, but this is just an information in case you really want to go deeper into your data analysis journey. So this is used to quantify the strength of the association between two events. So, for example, old people are at the higher odds of experiencing stroke compared to young persons. So understand these terms. So odds, likelihood, risk. So, but in this context, so it says hot, the likelihood, or how do you quantify? So most times when you look at the odds ratios, so they say um maybe 0.5% more likely or 50% more likely to experience stroke compared to young persons. So that is comparing two groups together. So percentile is used to compare to others within the distribution in terms of percentage. So when somebody says, "Oh, I'm in the top 90 percentile in my class in terms of grade," so some can say, "Oh, this product is the top 90th percentile for us." So all of these are just things that you can use to, in a way, talk about your analysis or your results. So quartiles, they are used to compare to others in the distribution, used in terms of dividing the distribution into four groups. Like I said, some of these terms you probably might never get to use them, but just so you can have an idea when people speak about them. So we have the Q1, the Q2, the Q3. So this Q1, Q2, Q3 is the Q2 is like the median, the Q3 is like the 75 percentile, while Q1 is like the 25 percentile. So when we talk about how to identify an outlier, remember an outlier is that value that sort of goes away from the normal distribution of the data. When I spoke about somebody spending $100 every week, but in a particular week, he spent $2 or he spent $7. So you would use this quartile. There's a formula you use called interquartile range to sort of get if a value is actually an outlier or not, but we'll not be talking about that today. So there are like a lot of statistical like concept that you want to learn. Just be curious at this point if you really care about learning about data analysis. If someone is talking about statistics, you find them talking about it in a textbook, a video. Just be curious to like get to learn, or what are they saying, and also be open-minded to want to learn about statistics. So have an idea of it. You don't necessarily have to know everything. So I think that's one thing that you need to keep your mind to, and also learning is progression. So remember, the journey of 1,000 might start with a step. Those who are experts today were once a novice. Be curious and set goals, and remember you can do this. In case you want to learn more, you can do also subscribe to our YouTube channel, share to your friends, turn your notification bell so you don't miss any of our amazing content. And you can follow us on LinkedIn, Instagram, and Twitter at velonti.com. Thank you for your time.